everyone. So we've made this PowerPoint on pedigree analysis. You may have already gone through this, but I thought I'd add the audio recording as well just to really talk through each pedigree and really help you with those skills of analyzing in pedigree for, what kind of inheritance pattern is shown, and how can I work out the genotypes from the pedigree. These kind of skills are really important in next week's SAC. So for each of these examples, I want you to have, a spare piece of paper next to you so you can have a go yourself first, and then we can go through the answer afterwards. So feel free to pause the PowerPoint at any time, use as much time as you need. Feel free to pause it, email me for a bit of, guidance as well. So the first example is, 3 steps you want to be able to do. So to draw and label the pedigree, to determine the mode of inheritance, and to identify the possible genotypes of each individual. Okay, so the situation is an unaffected man and his wife, affected with the disease, have 3 children, 2 girls and 1 boy. One of their daughters is unaffected, while their son and second daughter have the disease. Their son has 2 children with an unaffected woman. Both their son and daughter have the disease. Okay, so first thing, draw and label the pedigree, determine the mode of inheritance, and identify the possible genotypes of each individual. Okay, so here's the sample answer for number 1. So I've drawn my pedigree on the left. Now what I've forgotten to do is to number each individual. So making sure that you've numbered each generation using Roman numerals and you've numbered each individual using numbers. Okay, I've shaded the ones that are affected. Now looking at my pedigree, it's most likely dominant because it's present in every generation. Okay, the next one is there equal proportions of affected males and females, roughly, which tells me it's unlikely to be X-linked. Okay, but next thing is I would like to go and find some evidence that it can't be X-linked if possible. Okay, so what I can see here is I've got an unaffected mother, okay, who's got an affected son. So if this was X-linked, so let's say she would have this genotype if it was X-linked because she's unaffected, so she's homozygous recessive. The son receives his X chromosome from the mother. So that means the son's genotype would have to be this, which would mean that he would have to be unaffected. Because that's not the case, I know that it can't be X-linked, okay? So an unaffected mother has an affected son, so that means it cannot be X-linked, okay? So that's another key little piece of evidence. So while we're still practicing, what I would do first, is it recessive or dominant first, okay? Is it is it more likely autosomal? Is it more likely X-linked? Can I, find any evidence for that being the case as well? Okay, example 2. So determine the mode of inheritance. So I've got a pedigree already drawn up. Identify the possible genotypes of the circled individuals. Okay, so the answer for this pedigree. So looking in this pedigree, key things I'm going to look at is, does it skip a generation? So what I can see here is it's present in generation 1. In generation 2, there's a couple here that are unaffected, however they have an affected child. So I can say that it's going to be recessive. All right, so that's my first thing. Now I look to see whether is it going to be more likely autosomal or is it more likely to be X-linked. Now I can see already that there's equal proportions of males and females affected. So, it's unlikely that it's going to be X-linked because I don't see that difference in numbers. I also see that the mother in the first generation here is affected. However, she has an unaffected son, so it cannot be X-linked. Okay, so key thing, so that must be autosomal. The next question is, what are the genotypes of the circled individuals? So if I look at this one here, down here, okay, he's a male, okay, and he's unaffected. So if we think that the trait is unaffected, he's got an affected mother, so let's use the letters, those ones. That person, the mother, has to be autosomal recessive. She's got to be homozygous recessive because she has the disease. Okay. Now, because all the children, there's still some affected children, so I know that the father must be heterozygous, because there is still a chance that they're going to have some affected, some unaffected. Okay, so then I look at, what would 9 be? So I'm going to draw myself a little Punnett square up the top. So I've got the mother, the father. Going to fill in my Punnett square. Okay, so number 9 is unaffected. So what does his genotype have to be? It's got to be heterozygous. Okay, the other individual, number 19, has the trait or has the disease. It's autosomal recessive, so this person must be homozygous recessive. Okay, example number 3. Determine the mode of inheritance. Identify the possible genotypes of the circled individuals. Now this one hasn't been numbered, so really key thing to make sure you're numbering your pedigrees as well. Okay, so when you're identifying this, are there couples who are unaffected who have affected children? Okay, so the answer to question 3. So here I've got my pedigree. I can see that it's present in every generation. It doesn't skip a generation, so it's more likely going to be dominant. I see that there's more females affected than males, so it's more likely going to be X-linked dominant. Because they receive or inherit 2 copies of the X chromosome, it's more likely that they're going to inherit an affected chromosome. Okay, that X chromosome with that affected allele. Now, in terms of evidence, I can see that I have an affected mother over here who has an unaffected son. So she's most likely a carrier in order for her son to receive that recessive allele and be unaffected. Another piece of evidence is that the affected father has affected daughters, so they would have received that affected allele from their father. In terms of genotypes of the circled individuals, now because it's X-linked and he's male and it's dominant, let's use letter B. He would have that genotype. So he's got the dominant allele on the X chromosome and he's obviously XY. Now, because of the mother, she's unaffected, so that would have to be hers. Now I'm finding out that genotype to tell me what the genotypes of the children would be. Now all the daughters would be carriers, so they would have 1 copy of the dominant, 1 copy of the recessive. Okay, so I'm looking at these ones. This will help me with my next circled individual. Okay, so looking at these ones, the daughter's also affected. Now, because she's receiving 1 from dad, 1 from mom, she could actually be heterozygous, so receive the dominant allele from both, or she could receive the dominant allele from her dad and the recessive allele from mom, so she could be either of those. Okay, so example 4. So pedigree down below, determine the mode of inheritance, give 2 points of evidence to support your answer, and identify the possible genotypes of circled individuals. Okay, so the answer to example 4. So my pedigree here. Now you could go through and number your individuals. I'm just going to go through the pieces of evidence. So in terms of what I think it is, I can see that it doesn't skip a generation. So while it's not present down this family line, that doesn't necessarily mean that it's recessive. Okay, what I can see, it doesn't skip a generation. That's my really clue. So it's passed down to the daughter, who's passed down again, passed down to son, passed down again. So that's a suggestion that it's going to be dominant. In terms of autosomal or X-linked, I can see that the rough, the proportions between males and females is equal, so it's unlikely going to be X-linked. So I need a concrete piece of evidence. So I'm going to see that the affected father, so 2-7, I can see here, has an unaffected daughter. So that tells me that it can't be X-linked dominant. Okay, so key piece of evidence. So I know that it must be autosomal dominant. In terms of genotypes, let me use, let's say, the letter D. So because I can see that the father has a mixture of affected and unaffected individuals, I know that mother's going to be that. He's got to be a carrier, okay? If he was homozygous dominant, then all the children would have the disease, okay? So he must be a carrier. So then the daughter, again, I know must be heterozygous. When I look over here at the other one, got to be that one, because this other circled individual is unaffected, must be homozygous recessive because she doesn't show the trait. Okay, example 5. So the pedigree below, determine the mode of inheritance, 2 points of evidence, and identify the genotypes of the circled individuals. Okay, so the answer to number 5. So I can see here that it skips a generation because it's not present in generation 1, however it's present in generation 2. Okay, so that tells me that it's recessive. I'm going to look at now in terms of males and females. Yes, the ratio is equal. Doesn't necessarily tell me that it's not X-linked, so I need to look for specific evidence. I can see that unaffected father has an affected daughter. Now, because if it was X-linked recessive, she would have had to receive 2 copies of that affected X chromosome. Therefore, the father would have had to have that affected X chromosome, and he would show the trait because he only has 1 X chromosome. Okay, so really just going through these steps and these logic in your head just to become familiar with it. So I know that it's autosomal recessive, so now I just need to think of what the possible genotypes are. So let's use the letter A. Okay, so in order to have the trait, you must be homozygous recessive, so I can work out these individuals pretty easy. Now, if it skips a generation, then I know that they must both be carriers. So the first individual must be heterozygous. Okay, so example number 6, mode of inheritance, 2 points of evidence, and possible genotypes. So really look closely at this one. Try to, find some evidence to suggest, is it dominant or recessive? Is it autosomal? Is it sex-linked? Is it X-linked? Or is it Y-linked? Okay, the answer to number 6. So first thing I can see is that it skips a generation. It's not present in generation 1, however it's present in generation 2. And then I can see that this couple here are unaffected, however they have an affected child. So I know it must be recessive. Okay, I can also notice that mostly males are affected, so I can't see any females affected. So very likely to be X-linked recessive. Okay. Now, I might jump to the conclusion and say, oh, well, only males are affected, it must be Y-linked. However, very important point is that if it's Y-linked, it must go down from generation to generation through the fathers. And you'll see this in the case study booklet as well. So if a father has it, his son will have it, and his son will have it, and his son will have it. So because that Y chromosome is passed down from father to son. Okay, so what I can see is if I trace back from this one, he has the disease, however his father does not have the disease. So I know that it cannot be Y-linked. Okay, really important thing there. So let's look at genotypes. So it's X-linked recessive. I've got the males here. Let's use letter B again. Must be that one with a Y. Lowercase with a Y. Lowercase with a Y. So therefore the unaffected male must have the uppercase with a Y. Okay guys, so those are some good examples of pedigree analysis. If you have any questions or you're unfamiliar with any of those methods of analyzing, please email me and I can go through some more examples with you and just explain it in some more detail. Thanks.